Hi, in this lecture, I'd like to give you a demonstration of the upgraded application, the upgraded full stack application. And I'm going to start with the hardware side first, and then we'll go over to the computer on the browser and show you what the new upgrade application looks like on that side. Here, I've got the old full stack application up here. It's implemented on a Raspberry Pi 4 with an Arduino, and I've got the new one over the bottom here of the view. First of all, you're probably familiar already with the original full stack application, but just in case you're not, just wanted to highlight a few features. First of all, the application, of course, can operate on any Raspberry Pi. I've got it implemented on a Raspberry Pi 4 here. So the main feature on the hardware side of this application is that for communications between the nodes and the Raspberry Pi, I'm using two RF24 modules. Here's one on the Raspberry Pi, here's another one on the Arduino. For sensing environment, I'm using the classic DHT22 sensor. And on the Raspberry Pi side, I've got a small PCB just to make it easier to attach things to the header of the Raspberry Pi. And as you can see here, I've implemented a button and LED. There's actually a couple of LEDs here and headers for the devices. And that's about it. Now, the problem, as you can see on the hardware side with the original version of the full stack application, is that there's no feedback really. You don't really know what's going on in the system unless you go to the browser to check the environment conditions, look at the logs, etc. So this is one of the issues that I wanted to address with the new updated version of the application. Another issue that I wanted to improve on had to do both with the sensors and the communications. The DHT22 sensor is a little old. It's not really well implemented on the Raspberry Pi, on the Python that is, because of the way that its proprietary communications protocol works. It works well on the Arduino and microcontrollers, but not on microcomputers. So that caused things like delays and the application hanging and waiting for a long time, nothing happening. It was one thing that I wanted to improve. Another thing that I wanted to improve had to do with the RF24 module. The RF24 module is amazing, it's excellent really, especially when it works again on microcontrollers. But I found problems with its drivers on the Raspberry Pi, especially because, as you know, with my last Raspberry Pi full stack application update, the driver for the RF24 module did not support that latest version of Python. And I felt that the support was starting to fall behind the times. Also, getting the source code for the driver of the RF24 module, compiling it and then installing it was tedious. And I felt that for the purposes of this application, the result did not justify that amount of effort. So I wanted to improve all that. And here's the prototyping version of the upgraded Raspberry Pi full stack application down here. So immediately you'll see that the Raspberry Pi, for this implementation for the upgraded RPI full stack application, I'm using a Raspberry Pi 2W. So it's a Raspberry Pi 0 with wireless capability in its version 2 with an upgraded processor, so much faster than the original Raspberry Pi 0. Immediately, you'll see three things. Number one is that now I have a display. This display immediately gives me feedback on what's going on with the application and with the Raspberry Pi. I have implemented three different screens on this display. This one here shows me the time and the amount of space that is available on the SD card. It's one problem that I had with the original application. It's because of the logging that takes place on the SD card, on the database. The database size would increase over time. I didn't really know how much space was left without having to go into the command line, log on to the Raspberry Pi, and then check to see how much space is available. Now I just get instant feedback here. But I can also press on this button and the screen will cycle through statistics from the local sensor and from the remote sensor. So you can see this is device ID 1, which is the Raspberry Pi, and it's giving me environment information that is recorded and captured by the environment sensor on the Raspberry Pi device number 1. But if I press again on the button, then that will take me to the next screen. This is showing me details or environment data from device number 3, ID3, which is this ESP32 device, and the time and date when the last data set was captured from the ESP32. I think that is pretty good. This is showing me that things are happening, that the application is live. The LED here tells me when there is an update of the screen. Again, think of it as a heartbeat and know that the application is working. So just right from the beginning, just using the OLED display makes the usability of the full stack application much better in the new version rather than the old. In terms of communications, I'm now using the HC12 on both sides. I've got an entire section dedicated to the HC12. It's a really good, really reliable radio communications module. It uses the same frequency as the RF24, but it is now serial. So I'm using the UART serial interface on the ESP32 and on the Raspberry Pi. Very reliable, configurable. It doesn't have all of the bells and whistles of the RF24, but for the purposes of our application, it's more than enough. Communications are easy. As I said, simply use the serial interface and you're good to go. There's nothing really that you need to compile or set up on the Raspberry Pi other to turn on the UART interface. There's nothing to compile, no drivers. It's very simple. So this is a big plus of the application. It simplified things and increased reliability. I've also replaced the DHT24 sensor with the BME 280, which is very well supported on the Raspberry Pi. The drivers are easy to download for Python. There's nothing to compile, just plug and play. And again, that's another way to simplify the application itself, which means that you can now do more with this application. You can extend it and add more features like I've done with the OLED display and a few other things that I'll show you on the software side later. Instead of fighting constantly to get things like communications working and working out how to increase the reliability of the DHT22 sensor on the Raspberry Pi. Another modification that I've done compared to the original is that I'm using the ESP32 microcontroller. You don't really need to do that. The application on the Arduino side or on the remote side can work on pretty much any Arduino compatible device you want. There's nothing that requires the ESP32 here. I'm not even using the Wi-Fi module. You could easily use an Arduino Uno or an Arduino Mini. It's just going to work as long as you've got a UART serial interface available for the HC12 transceiver and an I2C channel or interface for the sensor. Your remote node is going to work. But I thought I'd just use an ESP32 because I've got a lot of those modules. So I didn't have to go out looking for new devices to implement here. Before we go over to the software side, just wanted to show you the PCB. So I have designed a PCB here. Give you a closer look if possible. So there's a new PCB. Once I have completed testing the prototype of the new full stack application, then I'm going to implement the components on this PCB and tidy up the circuit here. I've got a PCB that supports not just the hardware that you see on display here on these breadboards, but I've got additional buttons and LEDs so that you can implement additional functions with those additional components if you want. So for example, you can have an additional button here that could trigger an email. For example, you press the second button. This is number 1 button. You can have another button here, number 2. You press that button and then the Raspberry Pi will send you an email that summarizes things such as current environment conditions on remote and local device, time and date, where the report was generated, and how much space is available. Little things like that you could do once you have the available hardware here. Okay, so that is with the hardware side. Let's go over to my computer now, and I'll show you what's happening on that side. Now let's have a look at the upgraded Raspberry Pi full stack application on the software side. First of all, let's have a look at the lab app application directory. So both applications are very similar in the way that they're structured. The new one basically builds on the old one. There's modifications that have to do with the new hardware that is being used. The replacement of the RF24 is the HC12 receiver. So you see that I've got a new script here for the receiver to replace the script for the old receiver. Then there is another script for the new hardware that did not exist in the original application, which is a script here, it's version 2, that handles the display. But then the files that make up the application itself, like labapp.py, exist on both sides. It's just the new version basically deals with the new hardware. There's also the logging application somewhere here. It's up here, env_log. You'll find it here as well. We're going to drill into the details of those files and these changes later on in this course. But from the get-go, you can see that the new application is based on the old one, so everything will look familiar if you have completed the original course, which of course I do recommend because I'm not going to be talking about the details that I've already covered in the original course. In terms of how the application looks like in the browser, you've got the new application on the left side and the original on the right side. I'm looking at the lab temp page that shows you the environment conditions on the Raspberry Pi, which is feeding data from the sensor that's connected to the Raspberry Pi. You can see it's almost identical. In the new one, I've got the pressure, which is a value that the BME 280 can provide, but the DHT22 did not, so you didn't have that reading in the original application. In the new application, to go to the history and the charts, you click on this link here, where in the old one, you'd click on one of those buttons. I thought we don't really need those buttons because they already exist in the history page. So let's do that. Click on that to go back, and I'm going to click on this 3-hour button to go back in the original application. Just rearrange the windows a little. Now, this is very familiar. Obviously, the structure is the same, except that the new application now has a single table where it combines the values from the sensor, so you can see them alongside each other with the same timestamp. The original did not have this feature. In the original, there are different tables for temperatures and humidities. You still get those in the new one. So let's go down here. You'll see the temperature table. So you can also get the graph from Google Charts. Just enlarge this a little. And there's a chart for pressure and the chart for humidity. So you now get 3 charts, and you get the 3 individual tables for the values: temperature, humidity, and pressure. Of course, the radio buttons here also work. So you get a 3-hour span by clicking on the 3 hours radio button, and everything adjusts to that time span, the tables and the charts. You get that in the old version, of course. Another big change is Plotly. So in the original, when you click on the Plotly button or link, the application will generate a Plotly chart, and then the link that is given back will take you to the Plotly website. So that was the capability of the Plotly Python module, which was stuck at version 3.10. At some point, Plotly changed the way that its Python module works. So I wanted to keep up with the times. So I wanted to go to the latest possible version of Plotly. So now when you click on the Create Plotly Plots, the plots are actually created and stored on the local machine. So if I click on the temperature plot, you'll see that a new tab opens up. I'm still on my local server on my Raspberry Pi, but now the temperature HTML file contains the data points and the chart locally. I'm not on Plotly anymore. And this is how the latest version of the Plotly Python module works, which means that the application now is up to date with Plotly's latest module. And this chart is interactive, so you can zoom in, you can double click to zoom out. There's widgets up here that you can use to interact with the chart. And this is the modern way of doing things, I guess. Let's go back and auto scale. And you can do that with humidity and, of course, with the pressure. So it's all there. So another thing that you can do that you were also able to do in the original version of this application is that you can now display the data that have been provided by a remote node. So my ESP32 node has got the ID 3, so I can retrieve the data for that node and you can see it here. I'm just going to limit that time range to 3 hours. There you go. So that is the data stored in the database in SQLite 3 that's come from, let's switch that back to 3 again. That's come from the remote node. And finally, another feature that existed in the original version of the application, but I've extended in the new one, is that you can still log your values to a Google Sheet. So in this case, you can see that I've got my Google Sheet, the humidity and the temperature are being logged. At some point here, I extended the application to also log the barometric pressure. So now I get all 3 values, both from the local and the remote node, recorded in my Google Sheet. So you can then use Google Sheet to create the charts, graphs, analyze the data. And as you can see, Google Sheets and logging also works. Now, one last thing that I want to show you is if this and that. In the original version of the application, I've got an if this then that trigger. So if a particular condition goes above the trigger, I think I used the temperature back then that would trigger an email notification. And this is an example of what that looks like. And the same capability exists now with the updated version, the upgraded version of the Raspberry Pi full stack. If this and that notifications also work. So this concludes the demonstration of the prototype of the upgraded version of the Raspberry Pi full stack application. Let's continue in the next section, which is section 2, where we'll have a closer look at the hardware that I'll be using to set up the new version of Raspberry Pi full stack.